Hey folks, I'm Vinay Prabhu, Chief Product Officer at Graphiant. So the first demo that I'm showing, this one's the only one that's pre-recorded, and it's just so I stumbled through copy-pasting IP addresses in the form. So essentially what we're showcasing here is the data exchange capabilities. You'll see that manifests itself in three broad steps. Essentially, how we have eased up logistical and communication functions is by first publishing a publisher inventory, essentially services that you want to showcase on a marketplace on the Graphiant fabric. Second, you're essentially getting a subscriber inventory, all your B2B partners who might want to consume this service on demand. And third is the invitation and an invite to these customers to really consume this application or service as they see fit from the location of their choice. All of these, really think of it as a switchboard. You get to build an inventory, match up subscribers to it on demand. You can have any-to-any communication securely with the routing, security, and policy constructs all built in by Graphiant, taking the logistical overhead for the operator away from them and essentially allowing them to really start, pause, disable service on demand. So like I mentioned, AI is a massive distributed publisher subscriber problem at a global scale. All of this data exchange needs to happen in three easy steps. The first step, like I mentioned, is creating the publisher inventory. Graphiant allows you to create a service, whether it's an application or a peering service. In this case, we have an AI Connect app. Think of a Stargate or a GPU service that I want to advertise to my business partners. I essentially let the producer define the location of this application and the prefixes that they want to advertise as part of the application. Once you create the service, it's as simple as creating a subscriber inventory. They can be either Graphiant or non-Graphiant. It doesn't really matter. You can connect to the Graphiant fabric via either methods. In this case, we're taking a Graphiant customer. You fill in the customer details, essentially the customer name, the email they want to use for getting the invite, and the sites they want to consume it from. The third step is you just match this customer or the subscriber to your inventory of published apps. It's as simple as just matching up the app name or the service name to the customer. In this case, we are saying, hey, you have a Salesforce company that's going to consume the AI Connect service. That could be a Stargate GPU farm. You really want to connect those services up. You allow them to consume this. You essentially set up the prefix you want to see, essentially handling all the NAT capabilities to obfuscate any overlapping IP addresses in that form. You see an invite.
So this is an internal app. It could also be an external app like Salesforce, but it could be a company.
Company-specific.
It doesn't matter. There's not specific inventory of apps that you support. It's just whatever.
Whatever apps that you want to publish into your publishing inventory. So think of it like your personal marketplace now. So just like you have your iPhone application marketplace, you have this for business-to-business connectivity for any app that you develop, build, and operate.
And so as you're doing this creation process, how are you connecting this connection to the governance side? How am I labeling this so that my policies can apply to what I do?
Really good question. So what we do here is we completely isolate this publisher and subscriber communication on a separate slice on the network. In fact, they have separate pairwise keys as well. So there's different security associations for every subscriber and publisher communication. So think of it, you've got your own private VPN tunnel across the globe for every publisher and subscriber combination. And since we are doing routing at the source, we can really give you visibility of who's communicating where, how, across the globe itself on the infrastructure.
Okay, but if this particular connection is transferring, say, financial data, how does the compliance folks know that I'm setting up a new PCI compliant or non-compliant connection?
Really good question. It'll be part of the next demo that I show you the visibility piece. So it's a great segue for me to jump into the second half of it. But yes, you'll see the application identified. You've tagged it, you've named it as a compliance or regulatory financial app here. You'll see that reflected in our data assurance dashboard, which then lets you drill down into every session that has ever taken place for that consumption of that application. So we'll dive into that in the next section really shortly. So like you can see here, what we have sent to the end user is an email, really a secure exchange of what they need to consume. They can accept the invite, choose where they want to consume the application from, and how they want to consume it in their network, so they can really solve their NATing issues over there. They can choose the sites, the LAN segments that are allowed to consume the application or service, and all the security and routing policy constructs are auto-generated by Graphiant for you. And that's it. In 3 easy steps, what took months to really build out takes minutes on the Graphiant portal. You don't need a demilitarized zone setup. You don't need emails exchanged and text exchange or pre-shared keys flying over the internet. You don't need all of that. For a non-Graphiant customer, the experience is exactly the same. The email that goes out to you, you get a one-time username and password to really go in and download your security VPN profile based on the vendor that you're operating at your end. So you essentially, we see it in the financial sectors where there are credit unions that really don't have the IT capabilities to really configure these boxes. All they want is a configuration that they can pick up securely. And the publishers don't really want to sit and keep contacting each of those satellite offices constantly and keeping the logistical overhead. The key rotations happen automatically. You get notified. You come here, pick up the config, paste it on your Juniper or Cisco box, and you're good to go.
So I have a question for you,
Yeah.
Kevin Myers. This connectivity to your box, that's EBGP. It's their ASN to your ASN, essentially. Is that it's all routing,
Yeah,
whether it's IPv4 or IPv6?
Yes.
That's the handoff
Yes,
to the customer.
Exactly.
Okay.
So, and then we are using the BGP attributes to really give preference on where you want to land that service, through which gateway do you want to consume it, so on and so forth. So
Gotcha.
you will have all the load balancing capabilities for really consuming the application from the closest gateway point you want to enter the Graphiant fabric.
I think I heard someone mention that SRv6 is involved in your transport.
Yes, so we use a form of SRv6 to really show you the visibility piece of it. But yes, I'll show that capability as part of the observability demo.
Gotcha. Okay, I'll wait for that. Thank you.
Okay. With that, I'll jump into the second piece of the demo. So what we have here is Graphiant's data assurance dashboard. Essentially, what it provides is the visibility of all the applications that are running on the infrastructure, who's producing them, who's consuming them, and how they are being set in motion across the globe. What's enabling this is a real-time telemetry streaming pipeline that's built by folks from Netflix, Disney Streaming, and Oracle, who can really munch that data. We wanted to bring that streaming experience into the networking world as well. So what we can do is really consume millions of records with sub-second latencies from all the network elements in our infrastructure. What you see over here on the left, the 5.6 million records that have flowed into the system are munched in real time, compressed down to 3,700 applications that are actually running on the platform itself, on this network. And these 3,700 apps really compressed down into 15 malicious applications that you need to quarantine or really get out of your network. With a click of a button, you can see those application endpoints, these servers that we deem as malicious. You get to see their threat score, their risk status. You get to see the resource category of why we think these are malicious, and the ability to really see the blast radius of who was consuming it, which sites, which devices, which regions were involved, and the ability to block this with a click of a button. Let's say your network's running clean.
Can you go back to that?
Yeah.
So how do I look at the details under that particular one so that I can trust that I want to
The-
go ahead and do this?
Absolutely. So we show you even why we deem it as malicious. We tell you all the threat intel associated with it. So you'll get to see which nation state actors were involved, what are the other threat intelligence platforms telling you about this endpoint.
What are the IOCs and why you're rating
Rating is that,
so
yes.
that I can actually trust the
Right.
ratings.
Exactly. So we are getting to drill that down right here. So what we have shown is the threat intel that we are sourcing for this endpoint, and you can really see all the factors that have gone into deeming this endpoint as malicious as well. So it's completely transparent to the end user as to why we rate this application as a high threat in your network.
Not that I don't trust you.
No, absolutely. You shouldn't. That's why the observability piece.
So follow-up question for you on that. If you're taking traffic that's routed in from your customers, how do you tell when you have like a spoofed endpoint in the threat assessment?
So the traffic, so we have a very server-centric view of the world. Like Arslan just mentioned, we are not decrypting any of your traffic. So we run it through a gamut of signals. So I'll walk you through how we are getting to this compression ratio as well. So what we do is every net flow or IP fix record is augmented with a DNS header. If we can see the DNS packet that's traversing our CPE device. If we can't, we have the DPI engine that's actually tracking it's a signature database. So I like to say, if it looks like a dog, smells like a dog, must be a dog kind of database to actually get a signature match on the application. Then we send these records upstream to the north side of the communication here, where we are marking it through a gamut of signals. So you don't have to really install this threat intel on the networking operating system itself, go through frequent upgrades to get more threat intel down to the devices. To avoid that, we run it through a URL database that's around 240 million URLs updated every hour. A threat intel a database of 10 million IPs updated every hour. A CDN IP database around 100 million IPs that are updated every hour. So we are trying to trying to identify the URL endpoint you're trying to talk to, trying to identify who the server side is in the communication, and then match it up against all of these threat intel databases to really figure out who that endpoint is, where it's located. For the spoofing question, right? I could be a provider in, let's say, China who is pretending to own an IP that really belongs.
Right, like AWS or Azure. It's very common spoof for an attack on the network.
So we have seen that. We have seen that at our customer sites, actually. We've seen an AWS IP actually picked up by a threat actor for a couple of hours, a nation state actor for a couple of hours. So that outer header, we're matching up. It's almost like a zero-day attack. We mark and sweep through all the IPs that we have ever seen in your network to really see if this IP that was deemed as safe has now been marked as malicious in intent because of new threat intelligence that has come in, even if it was spoofed.
Gotcha. And I'm assuming that goes in with the geofencing that you're doing in your policy, that if I suddenly see origin traffic from China or Russia or wherever it is, and my policy is to be continental US or whatever, that's
you can't go there anymore.
Regardless of whether or not it's spoofed, it falls under that policy.
It falls under that policy, and I'll showcase that. So you're going through a gamut of signals that really are enforced at the controller level. What it does for us is it takes the burden off the infrastructure guys, the IT guys. You don't need to sit and upgrade every router every time you get new threat intelligence or new signatures in. All of this intelligence is streamed real time into the platform. Any new threat intel, any new rules that come in that you want to enforce, get enforced at this control layer without really affecting it.
Is there any remediation that is done for these 15 potential threats?
Yes, you could block all of these with a click of a button. So I want to really block this. All I do is, hey, block, I don't trust this anymore. I really want to quarantine this out across the network infrastructure. It's not specific to a device. It could be across all LAN segments, all sites, all regions. Hey, I don't want this endpoint to ever be consumed by any of my hosts.
And what if now I've said I agree that that's a threat, and so things that fall in that same bucket in the future I can automatically stop.
You can automatically.
And they won't be showing up on my dashboard anymore.
Exactly.
And then the follow-up question is, I screwed up and I shouldn't have automatically done this. How do I see that that was what screwed up the connection that's randomly not coming to the piece that it should be coming from?
You'll see that in the block bucket. So I'll segue into how we categorize the intent of the application, but you're giving me great segues. So let's say you're running clean in your network, right? Hey, I have all my security and compliance issues sorted. There are no threats. 3,700 apps are still a lot of applications to monitor. So what we do is we neatly bucketize them based on their intent. Broadly speaking, you have the enterprise SaaS apps. These are the O365s of the world, the Salesforces of the world. The public internet apps, these are the general apps, the CNN.coms of the world, the YouTubes of the world. You have the AI apps. You'll have folks on my corporate network going to ChatGPT and OpenAI this morning. So, so you essentially get to see large buckets that you can ignore because you fairly know what the intention of the application that's running. You have the unsecure apps that you really wanted to quarantine anyway, that we've just showcased. And the blocked application, things that you might have intentionally or unintentionally blocked or dropped in your network, really showcase up in this block bucket. These could be policy constructs that you push to get something malicious out, or these could be ACLs that you accidentally pushed and are blocking legitimate traffic. So you start seeing what these network issues are, which applications are getting dropped, and for what reason, and the ability to unblock them right here because you get to see which policy is actually dropping them. Then you have your crown jewels, the apps that we were talking about, you're exchanging with your B2B partners or within your enterprise, essentially things that I want to exchange on this data fabric. Let's say I have the Google Cloud, the Gemini service that I'm consuming for my AI application. I get to see exactly where it's being consumed from. I can enforce compliance, but before I enforce compliance, I need to know where these are running. So what I do is I view the topology on that global backbone. This is the almost Uber-like feel that I was mentioning. You get to see both spatially and temporally of how this application was consumed. You get to see for the past day in a temporal fashion that this application was consumed within the North American boundaries. You get to see the exact locations that consumed it. You get to see the fiber links that were taken for this communication and all the telemetry along that path. You also get a spatial view of the world of all the sites that use this application. You get to see the hosts that use this. You even get to see every session this host ever had with that endpoint. And with one click, you get to see the exact path taken by that application for its consumption. The host sitting in someone's home office is taking the AT&T provider through our San Jose POPs, taking the AT&T provider through our US West POP that's directly peering into the Gemini service.
That's sweet.
Yeah. Well, sure. So what I'm seeing here is you're extending your value proposition in that people seem to test the water with NAS services and do partial. You're making a play for global because you give them all this extra value and simplify their life, which is a big thing lately. Just not enough people and time to go around.
Absolutely. So 3 things that we really want to do well: any-to-any connectivity, end-to-end observability, and absolute control. We want to do those 3 things really well, and those are the 3 fundamental pillars that we want to showcase. You can get connectivity into your business partners, into your cloud providers, into services like I just showed you. You get to see how that application is moving. It's fully auditable. So I like to say there are 2 personas that really consume this. The network persona really thinks of this as mean time to innocence. The application guys always want to blame the network for their application performance. Within 3 clicks, I can prove or disprove whether it's the network or not. I can show you the exact telemetry all along the path. I can show you the client and server details in no more than 3 clicks. From a security persona, I have absolute auditability of every session that's gone over this global network. So I can really get my compliance and regulatory affairs in order and enforce my security rules across the planet.
And when that ticket comes in from a particular client, I can search it from that direction as well, I assume.
Yes, exactly.
I've got a ticket from a client that had a problem with this server application at a particular time.
Exactly.
You can pull up that.
You can pull up this, and you'll see both a spatial and temporal form of that data. So from a security persona, I can quickly say, hey, this data has not left the US boundaries. At least I'm safe on that front. I go to the second order problem of the performance itself. But it doesn't matter which the endpoint is, whether it belongs to you or to your business partner, you can really track it in the same fashion.
So sometimes from a security perspective, the decision isn't cut that client off right away.
Yes.
Sometimes it's we need to understand what's occurring first.
Yes.
How deeply can you drill into what? Obviously, you can look at sessions, but can you look deeper than just simply the session data for for a client that's connected?
So from a connectivity perspective, you can pause the activity. You don't need to disconnect him completely, or you can redirect that traffic to your scrubbing endpoint to really see what's happening. From a payload perspective, we are not decrypting your data. That's fundamentally not what we want to do.
Sure.
And it stems from the fact as if you're decrypting data, we strongly believe that data should stay within your private boundaries. If I'm sending it out to someone else's cloud to really decrypt and scrub the data, it's only a matter of time that gets breached. There's no way one environment safer than the other. So we're not decrypting the payload. So if there's if the question is there malware or is it a phishing attack in an email, we wouldn't know. We are not looking into that.
You're not looking that deeply. Okay.
That deep.
That answers the question. Thank you.
Yeah, but we are pairing with partners that can really scrub that data. So, hey, I want to move this data. I need to scrub this, need to see more details into it. Just like I've paired with the Google services over here, you pair with your secure access provider to really scrub that.
Is there a product or something a customer's built that you're typically displacing? So you're using this instead of, talk about what those are, because I can imagine a few.
Absolutely. So think of the NAS space. People like to put things in buckets. From a connectivity perspective, this replaces your SD-WAN solution. So you have your SD-WAN vendor of the world. From a visibility and observability perspective, you need another artificially probing kind of observability tool. Take say the Kentex and the Thousand Eyes of the world. For your cloud exchange, to get to your cloud, you have a third provider, a third vendor per se. Take say the packet fabrics and the megaports of the world. So essentially, what we see in the networking domain, at least in the enterprise space, is 3 or more vendors building a single enterprise network. It's a very vendor-centric model, and the enterprise network is pretending to be one network. It's 3 or more networks pretending to be one. Add a B2B partner into the mix, it's 3 or more vendors he has. So you essentially have 6 or more networks trying to exchange data. That's why the second order problem of another observability tool comes in place. There's no way to see how that traffic's moving. All you can do is guesstimate what's happening through probing those 3 networks. That brings you to those tools like the Kentex, the Thousand Eyes of the world that have a space because of the vendor sprawl. If you really unify it as a fabric, now you can see not through artificial probing, through your actual data, how that data is in motion across the planet. If I can see how that data moves, it helps you to really enforce compliance. And that's a problem in the enterprise space too. You'll see almost any enterprise network look like a hub and spoke. And why? Because I can't have a unified policy construct across 3 or more networks. I need to get my data to a scrubbing point, a hub facility where I enforce policy. 2 problems emerge from it. A single point of failure. You need to keep those data centers up. The tunnel sprawl, everything goes to the hub. So you need to buy a massive router that can hold those tunnels up and keep them up and running. And second, you fat finger one policy into that policy construct, and that's it. You're out of luck, right? Data is moving out of your jurisdiction before you know it. Once you get it into a fabric, you can really see how your data is moving, and you can enforce it at all the edges that exist in your infrastructure. You can block it out of where you don't want it to be, and you can consume it from where you want to consume it.
So just a question on that, Dustin, how much customability do you guys allow for policies? Coming from an MSP space, there might be certain times in the day where we don't want customers accessing certain applications, certain services. What sort of customability do you guys offer within, that regard?
So from an MSP perspective, essentially, we have route level policies, programmability of the backbone that's unique to Graphiant itself. You have, I like to put it in, again, 3 buckets, right? You have the path assurance, the performance assurance, and risk assurance. These are the 3 kinds of policy constructs I like to think of. The risk assurance states that, hey, I want to stay within compliant boundaries, within geopolitical boundaries. This is HIPAA data, this is GDPR data. My data is my most sovereign asset, and this is where it should reside. And my laws should apply wherever the data moves. The performance assurance policy, essentially, hey, I have X-ray files that I can't really compress. I want bandwidth to be the highest priority across this backbone. I don't care about the latency. So you can get performance style of policy constructs. And the path assurance is you can even control what links and providers you want to go on. Let's say I'm part of the defense sector and I don't trust some kind of equipment coming from a particular nation or state. I can control exactly which providers, which links I use to exchange their data on the platform. So you can really move through all these dimensions automatically based on your pipeline. All of these are exposed as APIs. So people integrate it into their APIs. Our customers typically put it into their pipeline. So as applications are developed, the policy constructs are auto-generated, ports are opened up where they need to be, and they're restricted where they need to be, so that the consumption of a new application is completely agnostic to the developer of the application itself. So the last piece of the puzzle, in the interest of time, is the enforcement of the compliance. Now that I know how this data is moving, I can really enforce policy on that data. I can say across my sites, across the enterprise, for all the LAN segments, whether it be corporate or guest Wi-Fi, I want a topology selected. That could be, hey, for a lack of a better term, GDPR or HIPAA or some topology that I want this data to stay within.
And this has a log option, so I can log it first, so I can look at what's going to be logged before I.
Yes. You can just log all of these, all the policy constructs that I mentioned.
Yeah, not that I don't trust.
So essentially, all of the policy constructs have the logging option, so you can really simulate what's going to happen beforehand. With that, and in the interest of time, I will dive into the last demo unless there are any other questions on.
I have one quick question for you, Kevin Myers. So you've built the box, you've built a transport network, and I realize you have a virtual appliance as well, so that you enter the Graphiant network to be able to take advantage of the data assurance and all of that. Yeah. What happens if the Graphiant network has a bad day? What is that? You mentioned that you're trying to get beyond being a transport network and have the solution exist outside of your own transport network. Customers are establishing a BGP peering with you. Do they just route around it and they lose that capability? What's the plan for that kind of a scenario?
So for our backbone networks, we want to get the best of both worlds. That's what Graphiant was built on. SD-WAN, that's just using the internet, throwing the packet on the ether of the internet, hoping it reaches the destination. And the MPLS style of the world, where you have absolute control and SLAs that you can guarantee because you own the infrastructure. From our backbone perspective, we have a resilient backbone. So we have redundant links, we have redundant POPs, all of the edges, in fact, auto scale out and scale back based on the availability of the nearest backbone node. There are redundancies on the provider at the edge. There are redundancy on the provider links facing the internet on the backbone itself. There's redundancy on the transport that's connecting the backbone links across the globe itself. So there's almost 3 levels of redundancies, and the device having intelligent to auto really move connections.
I guess that's really what I'm asking, because I'm sure you have plenty of redundancy built in to the architecture, but every network has a bad day.
Absolutely.
So if you do, and you have an issue there, you could write a policy that says, I will use the internet as my underlay to fail over if I so choose. Does the customer make that decision, or is that something you would plug into the Graphiant box and make that routing decision? What does that look like?
The customer could make a decision on that if they want to. The policy construct allows it to do so. But what we do automatically within the Graphiant software is to try and get you to the next available POP, next available link that gets your traffic on this private backbone. We want your private data to stay on the backbone and not really just go onto the underlay fabric.
Okay. So at the moment, if that is unavailable, that you're just going to drop the peering to the client, or it?
No. So it's think of it as two legs in completely different POPs. Like Seattle and San Jose both.
Oh, I mean, I get it. I build service providers, but sometimes you have things that affect the entire. You have an issue with the IGP or BGP. I guess the real crux of my question is if that's unavailable for whatever reason, if the redundancies are all unavailable, what's the expected behavior?
The expected behavior is if you have an underlay network that can really route the traffic out, you could have a policy construct saying, hey, this is my preferred, this is my backup preferred, and then, hey, this is just a fail safe. So you have the circuit of last resort. You have
the ability to define a policy that says, even though it may not meet the data requirements that I have, I'd rather have connectivity over the data assurance for a period of time, or not.
So people implemented the other way around generally is like, if it's a compliance requirement that this data doesn't really leave my jurisdiction, I'd rather just drop it, even if I have underlay connectivity.
Yeah, that's what I was getting at, is you can basically say, I would rather it be down than be non-compliant.
Non-compliant,
if that's your decision.
Exactly.
Okay.
So that's how, and this is because the source is routing it, unlike the internet where there's hop-by-hop routing where each one's making a decision independently. The source decides whether the entire path's compliant, if the label stack that they're going to put onto that packet header really is compliant for your regulatory needs. If you don't find an end-to-end path, you're just dropping that.
And that's why you're using SRv6.
That's why we're using it.
Okay, cool.
So the last piece of the puzzle, GINA, introducing Graphiant's Intelligent Network Assistant. Like I mentioned, she runs my stand-up meeting, buying back time for me. Things that used to take me 60 minutes, multiple teams, multiple touch points, multiple dashboards. I asked GINA to guide me into how I can access that data, what data is interesting. So she's not someone I'm just querying. She's giving me insights into what I should query and lets me run tasks that are important to me. So saving me time, essentially, by running my stand-up meeting in real time. So GINA is going to really tell me what data is interesting, what she has access to, and what I should be asking. She's going to give me insights on the operational state of my network. She's going to tell me what needs my attention from a security and compliance perspective, the malicious actors that I might want to get out of the network. She's going to give me insights into the compliance reports that I need to publish for my security officer to consume, and show me trends of where we can do better from a compliance and regulatory point of view as well. All of this action and activity happening autonomously as if she were a member of my staff. These questions typically take me through all the demos that I was showing you right now, drilling down into every session, trying to figure this data out, getting those reports in, talking to members of my backbone team that are managing the backbone network, the devices teams that are really monitoring the end devices, and my customer success teams that are really monitoring alerts that are coming across the planet. GINA has given me all of this information in 60 seconds. I know it's a blink and you miss it demo, but that's the intention of it. She's buying us time back, which is really valuable when you're trying to operate a global enterprise or a global network.
You're creating an AI agent based on what your physical employees, analysts are doing originally.
Yes.
And so you're taking the processes that they've validated over the previous year.
Yes.
And now you're automating that into AI on the data.
Exactly.
That's here.
That's here.
Okay. And now, obviously, this has been trained on the data that those people have generated to this point, right? How often do you do the retraining, and how often is the new data pushed in?
So we've taken a different approach. We're not trying to train the model on our data itself. That means we'll have to exchange customer data with the model. So we're not doing that at all. We're not doing that at all. The data is not used for training purposes. So what we're doing instead is giving the questions that are interesting to be interpreted by GINA to the model. So generative AI to just interpret what the questions are, and then giving GINA access only to the APIs that are accessible to us as users of the portal itself. So she doesn't get direct access into all the databases that we have in the backend. She gets as much or as little access as any user would to our portal. So you have RBAC capabilities just like a user would have. So she's getting only access to APIs or gRPC calls that have access for an end user. So what happens is she can now guide you to what she has access to, and she can answer questions what you would have wanted answered through the portal itself. So you secure what you're really exposing from an end user perspective. We want to err on the side of caution, and that's why we're trying to keep it as a closed system in terms of how we are operating this.
And from here, we can start to dive deeper on a particular branch.
Absolutely. You can
using that same
yes
process.
You could keep asking her more questions. What we've added on, why I say she's beyond a chatbot, she's a part of your workforce, is because she's carrying contextual awareness of what you've been asking across days, across months. So you can really ask her a question, and she's going to keep that contextual awareness that, hey, this is a CISO who's asking me for a compliance report. So the questions around threats, questions around compliance are more important to someone of that persona as compared to someone who's in product or in a backbone SRE team who wants to know about the alerts on the infrastructure or the CPEs that are leaking memory for some reason. So that contextual awareness makes her a member of your team that can really answer questions that are relevant to you and answer questions in the jurisdiction of the API she has access to, which are no more or no less than any one of the members on this portal.
And includes the public data that you have access to.
Yes, it includes the public data.
Right.
Yeah.
And is GINA available only for Graphiant networks, or does it work with other networks as well?
It's available on the Graphiant network. So if we kept it as a closed system, like I said, the infrastructure, the architecture supports being an MCP server to allow other agents to come in. We want to see how that plays out. It's a switch of a button for us to really expose it to other agents, but we really want to be cautious about exposing our customer data. Just like we don't want to decrypt any of your data, we don't want to give direct access to the data we are procuring on our end to other agents without her vetting of sorts. So GINA is a closed system for today, but the architecture is exactly like an MCP architecture. So enabling it is just a switch of a button.
You announced GINA today, right? You announced GINA today?
We announced.
Is it available today?
It is available.
GA? Okay.
In fact, all of what you saw is a live demo. This is corporate traffic. I was looking at it as real time as you all were. I didn't have this pre-canned. I was looking at folks running traffic, answering questions as we run through it.
So to put a finer point on what you were asking, so in a sense, it has role-based access because it's the user who's logging in, and then they have role-based access, and so GINA only has access to the data that user has access to. So, okay.
So kind of maybe another follow-up on that question. We've talked governance. Now we see a compliance report. Is there any way of maybe comparing where you sit currently against one of the security frameworks, for example, maybe PCI compliance or any of those things? Is there any way of comparing your current configuration, we'll say, to those reports that they're often have ran in?
Absolutely. So what we call it the gap score in our terminology. So you'll see the gap score, and she'll tell you the trend that it's increasing in this case. Essentially, what it means is the Graphiant Assurance Posture Score that you see over here. Think of it like a credit report inspired from credit reporting. You're losing or getting points docked from a total of 1,000 points for bad behavior.
Okay.
And we essentially then tell you what those behaviors are. So you can really start seeing how to improve your
But what about mapping that towards one of the frameworks that many organizations have to map their security?
So what we do there is we let the enterprise really dictate what compliance needs they have and what it means on the network infrastructure. So you saw a portion of the enforcing compliance where you can select the topology.
Mm-hmm.
That topology is actually programmed by Graphiant on behalf of the customer, made available to all industries within that jurisdiction. So let's say GDPR is common for almost everyone in the European Union. If one of the enterprises says, this is what GDPR means to me, it's likely the same for everyone else. We program that in our backbone, we program that in our gap score, and let you then check the trends of how you're doing against that metric.
Okay.